The chapter 5F is all about series. So the key to a series is the sum of all terms. Where the sequence is just a list of numbers, the sum, the series, is where we add them all together. Okay? That's really all I really want you to have out of this. Finite just means that the sequence ends. Infinite means that it goes on forever. So sometimes we can actually find the sum of an infinite one that goes on to forever if it converges to a finite number. We will not get to that yet. All right, so one way we can condense series notation is using sigma notation. This is the Greek letter symbol, sigma. And what we can do is use, anytime you see this just means the sum. This symbol means the sum of all terms. What are the terms being added together? All right, so first of all, if we look at this sequence of numbers, do you recognize these are all perfect squares? 1 is 1 squared, 4 is 2 squared, 9 is 3 squared, and so forth. It said write an expression for S sub n. All right, so S sub n is actually 1 squared plus 2 squared plus 3 squared, so forth, up to n squared. We're going to start at 1 and go all the way up to n. In sigma notation, your starting number goes at the bottom. Oh, they want you to use K. Notice this right here is your basic. K is your starting point. And we're going to go all the way up to N. And then we want our pattern in terms of K. So that's here. So you want to see what is changing each time. That's your K value. Notice if I plug 1 in, this would be 1 squared. Then I go to 2. I go up by whole numbers. So this is my starting point, and I go till I get to the top. Okay? This part, writing the sigma notation, I think is tricky. Actually, evaluating it's not terrible. All right, letter B, find S sub n for all these values. So S sub 1 is just the sum of the first term, which is 1. S sub 2 is 1 plus the second number, which is 4, which is 5. So S sub 3, we're taking the first term plus the second term plus the third term, which is 14. S sub 4, first term plus the second plus the third plus the fourth, which is 30. And S sub 5 is the first plus the second plus the third plus the fourth plus the last one, which is 55. So you're just working your way through evaluating each of the numbers. So here's some basic properties if you want to copy these down. This last one's going to come in handy here on the next problem. I'm going to tell you this isn't my favorite problem, but we're going to work with it. All right. So they give us a general pattern, the sum from 1 to n of 2k. So write the expansion or expand. So we start with 1. So 2 times 1 is 2, plus, because if we're using this sum notation, we need to add them together. Then I go from 1 and I go to 2. 2 times 2 is 4. See, this is where k is 1. This is when k is 2. Plus 6, that's when k is 3. 8 is when k is 4. And I'm going to go dot, dot, dot. Now, if I plug n in, do you see the very last term is 2n? Now, if you notice, what would be the term that comes before 2n? Do you see how each number is 2 less than the previous number? 2 less than the previous, or the one in front? So this one will be 2n, whatever this one is, minus 2 here. Okay, so that part is the expansion. Then it says, write it underneath, but in the reverse order. So I'm going to take this 2n and put it here. And then I'm going to take this term and put it under the 4. Then I need 1 to go with the 6. That's going to be 2n. Then I'd have minus 4. Then 2n minus 6. Then this will be, 2 is going to be underneath here. 4 is going to be underneath here. Dot, dot, dot in the middle. Then part B says, add everything together. So I'm going to add this, 2n plus 2. So I added these. Now I'm going to add these plus 2n minus 2 plus 4, 2n plus 2. Plus, now I'm going to add these. I'm adding the terms that kind of match up here. Oops, I'm trying to keep my colors to help. 2n plus 2 plus 2n minus 6 plus 8 is 2n. Notice the pattern here. Dot, dot, dot. When I add these together, 2n plus 2, 2n plus 2. So each time I'm adding 2n plus 2. So what they do, both of these are the summation. So we're going to say this here is the result of 2 of this sum. Okay? So the top, this is one of the sums plus 2 of the sums. So this combination is 2 summations. All right, now bear with me. I have n terms here, right? So I'm going to say there's n of 2n plus 2. But see, I can factor out that 2. That turns into 2n. You factor the 2 out front. So 2 of the summation equals this equation. And I can divide both sides by 2, which means the summation has the formula n times n plus 1. All right, that was some really complex math going on. Don't be afraid if you got lost a little bit. I wanted you to see the process, and little by little, you're going to get better at this, but don't freak out. That's not going to be on the test. And I think that's it.